The Gobi Desert remains one of the most unforgiving yet rewarding landscapes on Earth, a place where the fossils of the Cretaceous period are preserved with haunting, crystalline clarity. In 1923, the legendary Roy Chapman Andrews led an expedition into these dunes, seeking the origins of early humans, but stumbling upon a treasure trove of Mesozoic life instead. Among the discoveries was a peculiar skeleton, found perched atop a clutch of eggs. At first glance, the scene appeared to capture a moment of prehistoric predation frozen in time. The eggs were initially attributed to Protoceratops, a common herbivore of the region, leading researchers to believe this new predator had died while raiding another dinosaur's nest. Henry Fairfield Osborn, the influential president of the American Museum of Natural History, examined the find and gave the creature a name that would define its legacy for decades. He dubbed it Oviraptor Philoceratops, which literally translates to egg thief that loves ceratopsians. It was a branding that immediately condemned the species in the eyes of the public. Osborn noted that the skull of the Oviraptor was positioned just inches from the eggs, suggesting it had been caught red-handed in a final, desperate act of scavenging. For the next 70 years, this narrative took hold. Textbooks, museum displays, and documentaries portrayed Oviraptor as a specialized thief, roaming the desert to steal the progeny of others. The creature's unique anatomy, particularly its toothless beak and powerful jaws, was interpreted through this lens of egg-crushing utility, reinforcing the initial scientific bias. However, the story of Oviraptor serves as a profound lesson in how initial assumptions can blind us to the complexities of the natural world and the truth of evolution. In science, a single piece of evidence is often enough to spark a hypothesis, but it requires a mountain of verification to prevent that hypothesis from becoming a dogma. The egg thief moniker was a taxonomic tragedy, a name rooted in a misunderstanding that would eventually require a revolutionary discovery to overturn and correct. The Gobi Desert guarded its secrets for decades more, as the political climate of the mid-20th century limited access to the fossil-rich beds of the Nemegt Formation. It wasn't until the 1990s that a new era of collaboration began, bringing international teams back to the Flaming Cliffs with more advanced technology and a fresh perspective. In 1993, a team from the American Museum of Natural History discovered another Oviraptorid specimen that would shatter the long-held thief narrative once and for all. This specimen, nicknamed Big Mama, was found in a stunningly preserved brooding posture, her limbs draped protectively over a nest of 22 eggs arranged in a circle. Unlike the 1923 find, this discovery was unambiguous. The dinosaur wasn't there to eat the eggs. She was there to protect and incubate them with maternal care. The most definitive proof came from inside the eggs themselves. When researchers performed a CT scan on one of the unhatched eggs, they found a surprise within. The embryo inside the egg was not a Protoceratops. It was a tiny, perfectly formed Oviraptorid, proving that the eggs belonged to the very creature suspected of stealing them. The realization was electric. The egg thief was actually one of the most dedicated parents in the dinosaur kingdom, sacrificing its life to stay with its offspring. This revelation forced a complete reevaluation of Oviraptor's anatomy. The specialized beak was not for crushing stolen shells, but perhaps for a more varied omnivorous diet. Its powerful jaws might have been used to crack hard seeds or nuts, or even to consume small prey, much like modern birds that share a similar skull architecture. The discovery also provided a vital link between dinosaurs and modern birds. The brooding behavior of Oviraptor is remarkably similar to that seen in ostriches and emus today. This wasn't just a correction of a single mistake. It was a paradigm shift in how we perceived the emotional and social lives of these ancient reptiles. It suggested that complex parental investment and nurturing instincts had evolved millions of years before the first true birds took to the skies. The irony of the situation remains striking. According to the rules of biological nomenclature, once a name is officially given, it can almost never be changed. Despite its innocence, this dinosaur is legally and scientifically bound to be called the egg thief for as long as our modern classification system exists. It serves as a permanent monument to the fallibility of human observation and the importance of revisiting old data with new perspectives and better tools. But the story goes deeper than just a name. It challenges us to look beyond the surface of a fossil and consider the dynamic life that once animated those bones. Oviraptor belonged to a group called the Maniraptoranans, a clade characterized by their long arms, 3-fingered hands, and a specialized bone in their wrist. These features were once thought to be exclusively for hunting, but in the context of brooding, they take on a new, more protective meaning. The feathers of Oviraptor, though not preserved in the initial Gobi finds, are now believed to have played a crucial role in temperature regulation for the nest. The long, veined feathers on their arms would have acted like a living umbrella, shielding the delicate eggs from the harsh sun or the occasional desert storm. This discovery transformed Oviraptor from a villain of the prehistoric world into a symbol of devotion, resilience, and survival against the odds. As we continue to uncover more about these animals, we find that the line between dinosaur and bird becomes increasingly blurred and indistinct. The Gobi Desert still holds many mysteries, with new species of oviraptorids being discovered every few years, each adding a new chapter to this unfolding saga. We now know of Gigantoraptor, a massive relative of Oviraptor that reached the size of a tyrannosaur, yet likely shared the same nurturing instincts. The diversity of this group suggests they were highly successful, adapting to various niches across the ancient landscapes of Asia and North America. Yet, for all their success, their story in the modern mind will always be tethered to that first mistaken identity in the sands of the Gobi. It serves as a cautionary tale for all scientists. The context in which we find evidence can be just as misleading as the lack of evidence itself. If Oviraptor had been found alone, without the nest, it might have been years before anyone even considered its potential for parental care. The fact that it died in the act of protecting its young is a poetic tragedy that has resonated with the public far more than its false reputation ever did. Today, museums around the world are updating their exhibits, replacing the egg thief labels with descriptions of a dedicated feathered guardian. The legacy of Oviraptor is now one of scientific redemption, proof that even the most entrenched errors can be corrected by the pursuit of truth. We are reminded that paleontology is not just about bones and rocks, it is about the stories we tell and our willingness to change them when the evidence demands it. The Oviraptor's name may never change, but our understanding of its spirit has been completely transformed by the very fossils that once condemned it. In the end, Oviraptor stands as a testament to the enduring mystery of the past and the infinite capacity for discovery that remains within the earth. As we look to the future, we must wonder how many other mistakes are currently sitting in museum drawers, waiting for the right person to ask the right question. The story of the egg thief is finished, but the saga of the oviraptorid dinosaurs continues to inspire and challenge us in equal measure. Science is a journey, not a destination, and sometimes the biggest mistakes lead us to the most beautiful and unexpected truths of our natural history.